far. We're going to take a quiz tomorrow specifically over section 3, but all of this stuff really builds on itself, so we're just doing some practice with everything up to this point, and then as we go through this handout, I'll talk specifically about which things would be on your quiz tomorrow. So the very first thing we did was talked about what it means to be a polynomial, and what are the qualifications? What do we see if we have a polynomial?
Multiple term exponent, or like no fraction.
All right, we have multiple terms. We can't have a fraction in the exponent. What else can't we have in an exponent?
Integers.
We can have positive integers, but we can't have negatives. So no negatives or fractions in our exponent. So is this first one a polynomial?
No.
And I said if not, explain why. So it's the fraction in the exponent. All right, B. This one's in factored form, but if I multiply it out, would it be a polynomial?
Yes.
Yes. So I said if it was, I wanted the degree and in behavior. So we have to think degree. If we multiplied this all out, it would be x to what power? This 3 doesn't have an x, so we have 2 x's here, 1 here, and 1 here. So degree is 4. In behavior,
Down.
yeah, we know if it's an even degree, it looks like a parabola, but there's a negative out in front, so it would flip it. So down. C, is this a polynomial?
Yes.
Degree? All right, notice I flipped the order on you. I didn't make it first. You have to look at all of them. In behavior, we're still looking at that term. So 5 tells me it's like a chair,
Up, down.
but the negative.
Down.
Up, down. Up, down.
It's normally down up, and since it's a negative 2 in front of that, x to the 5th.
You have to like rework.
Yeah. All right, D. Would this one be a polynomial?
Yes.
All right, if we multiply it out, we have 2 x's here, 1 here, and 4 here.
7.
What would the end behavior be?
Down.
Any questions there? Then the next one, I'm asking you some questions about a graph. So the minimum possible degree. First of all, can you tell me, does this one have an even or an odd degree? Even. How many turning points does it have? 3 turning points, so the degree has to be at least 1 larger than that, so my minimum degree would be 4. All right, domain and range. We haven't done that in a while. Domain is left to right. What would it hit? Thank you. So range is from the bottom up, so it's coming from negative infinity. It stops, the highest point is here, and the y value of that point is b. And it does hit it, so the b would get a bracket. All right, local extreme. So that means I want all the local max and local min points.
CD, ET.
All right, and which ones are they? Max or min? CD would be.
CD and
Mm-hmm.
local mins are ET.
Yeah. Good. All right. What do I mean when I say absolute extreme?
Highest.
The absolute highest on the graph. So an absolute max, the highest point on the entire graph is AB. What is my absolute min, the lowest point on the entire graph? There is none because my graph keeps going down forever. Do you guys remember talking about all this stuff? Okay. So then we started talking about writing the polynomials. So we had to talk about the difference between a factor and a zero. A zero is just a number of factors when you put the x with it. So if negative 3 is a zero, what would the factor be? And it said that one had a multiplicity of 4. Good. The next zero was 1, so I would put,
X minus 1.
and the multiplicity of that is, what's my degree so far?
7.
7. And I said degree 8, so we need one more.
X on.
And I said that 0 was a 0, so that's just a plain x. And you can put it anywhere. I typically write them in front, but if you put it at the end, that's okay too. If you put x plus 0 or x minus 0, that's not wrong. It's just not the cleanest way to write it. Alright. 4. Write the equation of the polynomial with the graph shown. Alright, so let's look at this graph. What are my zeros?
Negative 2 and 3.
And what do you notice about the negative 2?
Bounces.
Bounces, so it has a multiplicity of 2. And we also hit a 3. We can also tell what's the y-intercept of this graph. Okay. So if negative 2 is a 0, we have to have, and since it was a multiplicity of 2, that would be, if 3 is a 0, it gets,
X minus 1.
all right.
It's a negative.
Why would it be a negative?
Because it's the opposite.
Yeah, my end behavior is up, down, so we know it'll be a negative. Can we find out what this exact number is in front? Yes, how?
Plug it in. Plug it into it.
Yeah, put in 0 for x and set it equal to 4. And we already know it's going to be a negative.
Yeah.
So we get 2 squared is 4 times negative 3, so negative 12a equals 4. Divided by a is negative 1/3. So I have my polynomial. Any questions on that one?
Wait, why does it bounce at 6? Like, I don't get it.
It bounces at the
Well,
negative.
what I'm saying, when it goes up. Yeah.
Oh, why does it turn around here? That's just a turning point of the graph, so it has to do with transformations of the original equation. But we aren't really learning how to find those exact points. We're just worried about where it hits the axes. Other questions? All right, number 5. What is the quotient when this is divided by x plus 4? So what would we do? Synthetic division. What number goes outside?
Negative 4.
And then what would my coefficients be?
1, 0, negative 16, 0, 1, negative 16.
0, 1, 0, and negative 16. We've got a lot of missing powers here. All right, so the 1 comes down. 1 times negative 4 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 4 is 16. That adds to 0. 0 times negative 4 is 0. That adds to 0.
Can't get the facilities for that.
We don't need to do it again. We do it just ask if that specifically. and it gives us zeros.
Oh, wait, yeah,
We
we-
don't have to keep synthetic dividing because that gives us zeros.
Well,
It's just
I
that
also
string
asked
effects.
for-
Plus four is a factor.
Alright, so this is my remainder. The constant, this would be x, x squared, x cubed, x to the fourth, and x to the fifth. So my answer is x to the fifth minus 4x to the fourth. I can drop the zeros, plus x minus 4. And then I said, is it a factor? Yes. What does it mean to be a factor?
The remainder is zero.
The remainder is 0.
Miss Circle,
Yeah.
would we ever be able to do grouping issues?
Possibly, yes, if you had to keep going and factoring this, and that would be one you could do grouping to finish if I asked for the rest of the zeros.
Oh, no. Looking on out.
All right. That's probably the old stuff. This is where section 4.3 starts. So if you want to know what your quiz will look like tomorrow, look at questions 6, 7, 8, 9. This would be the type of stuff on your quiz.
It's gonna be 6, 8, 9.
So, number 6, we're writing a polynomial, or we have a polynomial, and I'm asking you for the remaining zeros. So I told you it's degree 8. So we should have 8 total zeros, right? I gave you 3 multiplicity of 2, so that's 2 of them. 6i, negative 4 minus i, and 3 plus 5i. What else would have to be a 0? I have 5 total so far, and I need 8 of them.
Plus or minus six.
Plus or minus all of them.
The conjugates. If 6i is a 0, what else has to be?
Negative 6i.
If negative 4 minus i is a 0, what else has to be?
How's it 4 plus
No,
the negative plus I? That's why I said.
You only change the sign on the i.
Yeah.
And if 3 plus 5i is, then the last one would be?
3 minus 5.
So I'll probably ask you a question like that, just testing if you realize that if you have an imaginary 0, you also have your conjugates. And I didn't ask you to write the polynomial or do anything else, so that's all we need to answer.
Good friggin' looks.
Alright, then we got into the graphing stuff last week. So, when I had you graph, I asked you all these questions, and I will ask it the same way on the quiz or a test. Degree. What would the degree of this be? 5. We have 2 x's here, 2 here, and 1 here. So degree is 5.
Up, down.
The negative flips my end behavior, so up, down. How could you always check that?
Graph.
Zeros and multiplicities. So what makes x minus 1 equal 0? Because it's squared, that's a multiplicity of 2. What makes x minus 3 0? 3 multiplicity 2. And x plus 4? Then I want to know for each of these, would you go through or balance? And remember, when we're deciding that, we are looking at the multiplicity.
Can we just draw arrows to them?
Mhm. So at 1, what would it do?
Bounce.
Bounce, because 2 is even. Alright? At 3, what would we do?
Bounce.
And at negative 4?
3.
Alright, how do we find the y-intercept?
Plug 0 in x.
So 0 minus 1 is negative 1 squared. 0 minus 3 is negative 3 squared. 0 plus 4 is 4.
Negative 36.
So now we have to put all this on the graph. On your graphs, make sure you are plotting the stuff that you found. So I have to put a point on my x-axis at negative 4, positive 1, and positive 3. I hit my y-axis at negative 36. I'm just going to draw a point and label it and say this is negative 36. We know the graph should start up and end down. It should be curved, no zigzags. You can't cross the axis anywhere except where we have points here. So we're going to come down and hit the negative 4. And what does my graph do at negative 4?
Cross.
Crosses or goes through. Okay, we have to hit the y-axis at 36. Come up At my 1, what does my graph do? Bounces. It's going to come back down. And at 4,
It bounces.
or sorry, at 3, it bounces and goes back down. So it should look something like this. Then let's do one like yesterday. All right.
Is 7 gonna be on this list?
Yeah, basically 6 on would be on your quiz. So when I look at this one, how do I know the maximum number of zeros? How many zeros should I expect? 3. Your zeros is the same as your degree. So my degree is also 3. Okay, in behavior. Okay, possible zeros. This was what we did yesterday. If I don't give you the first 0, we have to figure out what could be a 0. So we did P's and Q's. The P comes from the constant. I need everything that would divide 12 evenly.
1, plus or minus 1, plus or minus 2, 3, 4, 6, and 12.
Remember, they always get a plus or minus. And then we did our Q value. Q is from the leading coefficient. So what's everything that goes into 2?
1.
From that, we get the possible zeros. Remember, that's just P divided by Q. So again, we'll still have plus and minus. So 1 over 1 is 1. 1 over 2. 2 over 1 is 2. 2 over 2 is 1, and I've got it. 3 over 1. 3 over 2. 4 over 1. 4 over 2 is 2, and I've got it. 6 over 1. 6 over 2 is 3, we've got it. 12 over 1, and 12 divided by 2 is 6. So that's everything, all the nice zeros that could work. Now we have to find one so we have a starting point. And we had a couple options. We talked about plugging them in and finding one that makes it equal 0. What's another short way that we have to help find it? Graph it and look at an x-intercept. Okay? We try to avoid the fractions if we can. So graph this equation and see if you can tell an integer value where it would hit the axis. What do you think?
3.
3. What do we do once we have one? Synthetic division. So this is now back to the old problems where I gave you the first 0. So 2 comes down. 2 times 3 is 6. 6 plus 3 is 9. 27. So we get 2x squared plus 9x plus 4. What do we have to do? Slip and slide. So that factors into x plus 8, x plus 1, divided by 2 again. So we get x plus 4, 2x plus 1, and what else do we need? X minus 3, because the 3 was a 0. So that's my factored form. Then what are the zeros?
Negative 4, negative 1, and positive 2.
Were all of those on my original list?
Yes.
Yeah. Okay, through or bounce. They all have a multiplicity of 1. 1 is odd.
Through all.
Y-intercept, we can plug in a 0 for x. You can do it here or in the original, it doesn't matter.
2.
Should get negative 12. All for x is our 0. And then we can graph it.
Do we,
So my zeros, sorry, we have 3, negative 4, negative 1/2. My y-intercept, did we say negative 12? Okay. And we said our end behavior should start down here and end up here. We're going through all the zeros, so we should start, go through, come back.
Do we always bounce in our y-intercept?
You're not really bouncing, you're just going through it. Now it could like come down and come back and hit it or something like that too, but you're just going through that. So our graph looks something like this. What I will be looking for on test or quiz is making sure that your graph matches all the information you found. So make sure you don't just try to copy it from your graphing calculator, you're plotting all the stuff that I had you find and using that in your graph. All right. Questions there? One last review problem. All right, so I gave you a polynomial, and this time I gave you the first 0. If I give you the first 0, what do we have to do?
Subtract it.
So 3i is my 0. So 3 comes down. 3 times 3i is 9i. So now I have negative 1 plus 9i.
Did we also write this 9i?
Okay, now we have to multiply. We have to take 3i times the negative 1 plus 9i. So that would give me negative 3i plus 27i squared, which is, so my 27's drop and we just get negative 3i. Then 3i times negative 3i is negative 9i squared, which is, what would I do from here?
subtract again.
With?
Negative 3.
Right, because we know if you have one imaginary 0, the conjugate is also a 0. So 3 comes down. 3 times negative 3i is negative 9i. That adds to negative 1. Negative 1 times negative 3i is positive 3i, and that gives me 0. So I am left with 3x minus 1. The question was remaining 0. So you don't give me the first one, I already told you, but the others were negative 3i, and what would make 3x minus 1 equal 0?
Positive